Sudoku degenerates, welcome. Before I start doing the puzzles today, I wanted to show off this little project. There's this site where a bunch of people are trying to solve every possible 5x5 nonogram. I'll post this in puzzle suggestions as well, but in the meantime, I thought I'd try just a couple of these to warm up. Oh, this one looks lonely. Alright, let's see. How do I... Oh. Okay, well that's easy. A nonogram rules is, it's Picross. Like, this 5 means all of these are shaded. Okay, this is shaded, this is not. This is not shaded, this is... Oh, this is also a gimme. Done. Okay, this one looks a bit trickier. Well, I know all of these are done. Okay, that gets rid of those. Oh, hey, VFig. Oh, okay. Yeah, I am making... Oh, yeah, there. That one was easy. Alright, just... I'll do a couple more, then I'll switch over to the submissions for today. Okay. This is forced to be 2. Oh. Okay. There. Oh, that one looks a little like... Not sure what that looks like. Looks like an eye of some kind of face. Not sure. Oh, these are addictive. With this done, this is forced. Okay, yeah, that one was easy. Similarly... This 3 forces that. Well, this cannot be... Oh, so this has to be. There. Oh. Alright. Oh. Yeah, okay. I'm doing my part. Oh, this 2 clue rules that out, which forces the 3. Oh, and this 2 clue also forces that. Okay, Oh, is there a deadly pattern here? Oh, no. 1, 2... That's forced. Okay. There. And there. Nice. There's 24 million of them. And nonogram is basically the same as Picross or black and white Picross. Oh, thank you for the raid, Resender. How was your stream? Oh, 1 and 3, that's always forced. 5. Oh. Easy. All right. Okay. Well, I don't want to just do these the whole stream, even though I could probably do at least a few more rows of these. So I'll just I will give this a shout out in the setting in the stream team Discord. All right. Locomotive. I'm guessing that's train themed. Is it a management sim or? All right. Cross is my favorite Switch game. Yeah, there's some good ones on there. Oh, Jesus, really? That sucks. Okay, it's showing James Sinclair is offline. Oh, a pixel point-and-click murder mystery set on a train. That sounds fun. I might check that out. I'll have to remember to look that up. Oh, locomotive. That's why it's 2 words. No worries. Hey, Q. Oh, controller interface. I would mainly use the touch screen with that, though I guess that wouldn't work in docked mode. Hey, Jojo. Alright, this is Tenable by James Sinclair. Oh, hey, James, welcome. So I fill each row, column, and box with the digits 0 to 9 once each, with exactly 1 cell in each row, column, and box containing 2 digits. A cell's value is equal to the sum of its digits. Hey, Marty! Divide each line into 1 or more segments containing values that sum to a non-zero multiple of 10. Oh, interesting. So it's multiples of 10. So that every cell on a line is part of exactly 1 segment. A value in a circle indicates the number of segments on its line. Oh, for counting purposes, lines are divided into the smallest possible increments. A 1, 9, 2, 8 sequence is considered 2 segments, not 1. Okay. Hi, Alima. Welcome. Values in cells with inequality signs are greater than the values in all orthogonally adjacent cells, so this value is larger than this. And one of these has to be an S cell, because values cannot repeat, because that's the only way to get, because like these two are always going to have the same value. Now what's the minimum? I think the minimum value here is 3, because there's no way to add 2 distinct digits to make 1 or 2 without hey, Black Doom. So this is at least 3 segments. And for counting purposes, lines are divided into the smallest possible increments. Now, does the rule that each cell is part of exactly 1 segment mean that I can't have 0 on the edge of a segment? Well, it doesn't expressly say that, so maybe I should maybe I shouldn't assume that. I'm not sure it would be that helpful anyway. this can only be 1 or 2. And if it's 2, then one of these is an 8 and the other is an S cell. This can also only be 1 or 2. And the only digits that can go in a cell with a value of 1 or 2 are 0, 1, and 2. These... Wait, what about this? Ooh, that could actually... This could actually be 3. If, like, this was a segment and each of these were 2 S cells that summed to 10, then the S cells would be here? Oh, but that might break this. Huh, what does... What about... I know one of these has to be... these can't both have a value of 1, because they're in the same column. Similarly, these can't both have a value of 1, but this one, if this isn't 1, that doesn't necessarily mean the line has an S cell on it, because these could sum to 10 and these could sum to 10 with no S cells required. But here, okay, so I know that at least one of these lines has an S cell on it. Now, the maximum value these can have is 5, right? Because no matter what I do with this, there's no way to have more than 10, 10, 10, 10. In fact, I don't think it can be 5, because one of them would have to be an actual 5, and that takes 2 cells. Well, suppose this is the actual 5. That's a segment. That's a segment. Yeah, there's no way for even if I put it here, there's no way. Wait, is it? Yeah, because these sum to 45. Yeah, I don't think either of these can have a value of 5. Oh, and there's no 0 in either of these. So one of these is a 3 or 4, and the other is an S cell with 2 digits that sum to either a 1-2 pair or a 1-3 pair. So the 1 and 3 in this box are always in these cells. There's either a 3 with a 1-2 or a 4 with a 1-3. So either way, there's always a 1 in an S cell, and there's always a 3 in either the S cell or the normal cell. Now, what if it's 4? Well, one can go with a 6. The other... Oh, I think that breaks too, because, like, if one of these is a 4 and the other is 1-3, how are each of these part of 10 Oh, one of them could be part of a 20 segment. But no, if one of them is part of a 20 segment, they can't be 4 anyway. Does that... I think I've just proven that one of these is a 3 and the other is a 1-2 pair. So there's exactly 3 segments on this line. Okay. Oh, this cannot be the 1-2, otherwise this can only be 0, and that is very bad. So this is the 3, and it's green. This is the 1-2 S cell. Well, it was a little bifurcatory, but... I think... Well, if one of these is 4 and the other is 1-3, like, how are each of these parts of segments that sum to 10 or more? I don't think these can both be parts of segments that sum to 10. Oh, unless it's this? Oh, I think one of them could extend out here. Right, so I haven't... Right, okay. I do know this can't have a 2 in it because it breaks this. That logic is still valid. Hi, Adlaven. I believe yours is next in the queue. Yeah. Alright. So, what can I actually get? I know this either is a 3 or... Well, I know this either... If this is 3, this is 1-2. Or this is 1-3 with this being 4, or 4... Oh. Hi, Isaiah. Okay, so what can I actually... Is there an elegant way to rule 4 out of there, or to prove that it has to be 4? There's also the fact that these are all... Wait, this cannot be an S cell. This cannot be an S cell because it makes both of these have values of 2, which doesn't work. Okay, this is 3 or 4, and this is either 1, 2, or 1, 3. So this cannot have a 1 in it. I think this being a 2 doesn't work now, right? So I have to go with an 8, and then this would have to be an S. So, okay, this is not 2. This has a value of 1. And it's either a 1 or a 0, 1, and either way, that's not a 1. Now, that doesn't mean this isn't an S cell, but it does mean that these 3 cells, possibly 4 digits, sum to exactly 10. Oh, I also got a rule. Okay, so there's no 0 in here, because this isn't an S cell. Okay, so this is a 1, 2, 3 triple. Wait, how would this being 3 work? I guess if those were both S cells? Is that the only way that it works for this to be 3? Especially because if this is 3, then this is also 3. Yeah, I think that is the only way this line works if this is 3. I think this is also 2, 3, or 4, right? Well, it's possibly a an S cell, but it has a value of 2, 3, or 4. Well, no, I think this one could still have a value of 5 even. Okay, that is less... It's less useful than I'd hoped, but not totally useless. Alright, can I do anything with these yet? I'm not seeing anything obvious. I know that there's a 2 in here. And one of these, at least one of these, is an S cell. So what does that mean for... What does that mean for... Oh, I mean, if it's 4 stars, I'd say... Sure, I could use a vague hint. Is there some set theory? I mean, I know this has to sum to 5, 10, or 15. It doesn't actually rule much out. Same with this. Each of these has to sum to 5, 10, or 15. Oh, so that's not even the starting point. Okay. Now there's a 2 in here. What do I know about... Oh, hi, Carl. Welcome. This can't have a value of 1. It has a value of 2 or 3. If this is 2, this is 3. Oh, the only way this being 3 works is if these are both S cells, and I think the only way this being 2 works is if this is an S cell, and that contradicts. Okay. Okay, so this has a value of 1. Doesn't necessarily mean this isn't an S cell. Also green that to remind myself that that line is all one segment. Okay. And one of these values are 1 and 2 respectively. So that does make a 1-2 pair. The only question is whether the 1 goes with a 0 to make it an S cell or not. So 1 in this box has to go in these corners. If it goes in here, it's obviously part of an S cell. If I could somehow rule all of these out from being S cells, that would force this to be a 1. or at least to have a 1 in it. Do I know? I mean, what's the max value this can have? 7, right? The max value this can have is 7. I mean, obviously it being higher than this is easy. Being higher than all of these might be a little tricky. I wish there was some way of notating these have to be either 5 or 15. They can't be 10, because the line is... These values... Okay, Oh, so... Oh, one of these is an S cell. Because if one of them is 15, that is an S cell. And if they're both 5... Right, so there's an actual 5 in here along with an S cell. But that S cell could still have the 1 in it if it's 1, 4. I know the 1 doesn't go here, obviously. Now, whichever of these is an actual 5, that's going to put some pretty low digits around here. In fact, if these both have a value of 5... Oh, that breaks. So, in fact, one of these is a 5, and the other sum to 15. Because these can't all be lower than 5 and still have one of these sum to 5. I mean, I can't put a 1 in these at all. So if these both sum to 5, this is 0, 2, 3, 4... But that leaves no pair of digits that sum to 5 to go in here. Okay. So there's a 5 in one of these with some low digits next to it, on all sides, I will point out, and 15. Now, if this is 3, it's a 7. These are both S cells, so that's an S cell. So that sums to 15. And if this is 3, this is 7. This has to be 6, 9. Nice in that case. And that has to be 5. Not sure how that's wrong. Now, if this is an S cell, then this isn't, so this is, and this is 2. So one of these is the S cell in this column. But this only has a value of 1. So if it's here, it must be a 0, 1 pair. Oh, there's, Can this be 2 with this as an S cell? Then that's an S cell. There's another S cell up here. Meanwhile, if this is 2 with this is the S cell, this is... Huh. Alright, if this is 3, this is 4, is that... But of course... It only gets me so far. So what do I do with... Oh, there's... What do I do wait. Okay. This is 2. This is 4. If this is 3, this is 3. This is 2. Okay, but if this is 3, this is 4. 2. So these cannot have the same value. Oh, unless they're both 2? Yeah, they can't both be 3. So one of them must be a 2. Oh, that rolls 2 out of here. So this cannot actually be 7. It's a max of 6. Is that useful? Oh, right. 1 in this box. It has to go here. I deduced that earlier. Wait. Yeah, because I know there's a 1 in here. The only question is whether it goes with a 0 or not. Oh, which it has to... Obviously... Okay, I can't put... I have to put 0 somewhere in here, so I can't put a 0 in one of these and a 0 in one of these, because otherwise that would force the 0 up here. The 5 goes next to a 0, 2, or 4. To 2 digits from that group. Is that a roundabout way of proving that this has... Well, I mean, this has to be fairly high, right? What's the minimum this can actually be? I mean, there's probably a reason why it can't be 3, but I don't... Because this could be a 0-2 pair, right? Oh, this would be 0, this would be 2. Well, okay, I shouldn't start from that end either. There must be something simpler that I'm missing. one in this box only goes up here. Oh, in fact, it only goes in here, because the one in this row is here. Oh, and there's a one here. Okay, so there is a one in here, in this cell. I just don't know if it's an S cell or not. One in this box only goes here. One in this box only goes here. Because there's a one in here as well. So what can I say about... Yeah, I should have got this sooner, but I forgot I had already deduced that there was a 1 in the corner of this box by the time I deduced these. There's something it seems like you've gotten really close to a few times. Oh boy. Okay, so there's a 2, so one of these is an S cell. These are from 0 to 4, or these are from 0 to 4. Now, because of this, there's a 2. Okay, so this cannot be a 2, so the 2 in this box goes here. Presumably next to the 5. Okay, so this is a 3. That forces this. Okay, so this is just a 3. Okay, so that's 4. Okay. So that's 2. These sum to 10. This has to be 7. So this does not have a 7, which means it also doesn't have an 8. So this is either a 5 or a 6. Oh, and it must be a 6-9 pair. Nice. Oh, there's quite a few reasons why it must be. For one thing, that's the only spot left for the S cell. Okay, so these are from 0 to 4. This is not 2. I'm guessing this is the 2 in this box. I think it's still technically possible for it to go here, but we'll see. Okay. There's a 3 up here. Now, if it goes here, this is a 0 to 4. then this is either 0 or 1. Oh. Yeah, I also got to, Okay, so this isn't the 2. This is the 2. This is 8. And this is 1. Oh, this is also 1. These sum to 10, but they are not 3, 7, or 4, 6, or 1, 9. This is a 2, 8 pair. This isn't 1, 9, or 3, 7. This could be 2, 8, or it could be another 4, 6. Yes, I have done that on occasion when setting a puzzle. Okay. Now that this is 15, if this isn't 5, it has to be 1, and it can't be, so this is 5. Now this could be 6, but this can't be 2, 4, or 1, 5, so this does in fact have to be 6. Oh no, it could sum to 20. Or could these sum to 16? If this is 7, 9. No, because this... I don't think I can... I'll come back to this later. This isn't 2, 8. Oh, I can't? But this is 15. Oh, right. Yeah, this could be part of a 20. Or this could be part of a 30 section. That leaves 30 over here. Right. Okay. Yes. Yes. Thank you for... Oh, this is 1 in this box. Okay. I still technically haven't ruled 3 out of here yet, though I probably will. Okay, these sum to 9, and they're not 1, 8. This... Okay, this could be 7 with this being 2. This can't be 6, but it could be 3 with this being 6. And this could be 4 with this being 5, I think. Okay, what about here? Oh, this can't be 1, 8 or 2, 7. So it could be 6, 3, because this rules a 3 out of here. Or 4, 5. I don't think either of those is ruled out of anywhere yet. Now, since these two can't be the same digit, neither can these two. There is... Oh. One of these is 8. It's probably this. But I don't think I've proven it yet. Oh yeah, it could also be 0 and yeah, I wondered at the start whether you could have 0 on the edge of a segment, but I don't think the rules explicitly rule that out, so I'm going to assume it's allowed. Oh, right, yeah. It might still work in here because for counting purposes, lines are divided into the smallest possible increments. But the word possible might imply that if there is a 0 on the edge of this line, that still could get counted towards that. But it wouldn't be, but the 0 wouldn't be a separate segment. And the segments can sum to a non-zero multiple. The 0 wouldn't have to be a separate segment. It would be part of the 10 line. Yeah, I get that. I still... There a different way to rule? Two in this box can only go up here. Maybe I should look at that. I mean, it could be a 2-8 or it could be a 3-cell. Can't be 4-cell, but... Ah, okay. Ah. Fair point, Chinstrap. Okay, why are only some of the messages showing up in the chat box on the thing? That's weird. Huh, okay. I think for now... For now, I think I should pencil in 0 and 9 here just in case, and I might be able to rule them out of here at some point. That's fair. One in this... Oh, right, one in this box is here. So either this is 1 or this is a 1-9 pair. I mean, it's either here, which would make this a 0-2 pair. Oh, that would break this. Okay, so it's here. Probably here, because I know this is less than... And I know this is greater than 3, so I think... Oh, this can't be 5. Is this only... Wait, is this only 4 or 6? Because it can't be 7, because this can't be 2. Okay, so this is another 2-8 pair. So this is not 2. Okay, so this is 2, and this is 8. Oh, I guess that answers the question of whether 0 can go on the edge of a segment or not. Because doesn't this have to be 0? Yeah, it has to be 0. I said it has to be 0. So that's not 0, and that is not 9. This being 4 makes this 0, this 3. Oh, this can't be... You're right, yeah, this has to be 6. Okay, so this has a value of 1. This has a value of 3. Wait, what? Oh. Okay, there are more options for this. Okay, good to know. Oh, this could be 109. Right, okay. This being 4 doesn't work, though. So, in fact, this being 7 also doesn't work. It being 8 doesn't work. I think this is either 6 or 9. This could be S. No, it would be too big because these both have to be very small. And I guess this being 6 doesn't work for the same reason. Okay, I think this does have to be 9, and this has to be 0 and 1, and this is the S cell. My headphones keep trapping strands of my hair in between them and my ears, and it is a very annoying sensation. Alright, I guess the 0 in this box goes somewhere in here. If this is 0, this is 3. So this is either 0 or 3. Well, either explicitly saying it can't or explicitly saying it can, and having to prove that it never does. That could... But yeah, I do think picking one and making it clear which of those two options it is would... Seven in row 6. Ooh, yeah. Makes this 3. Two, 4, 5, 6, 8. I think if this is a 2-4 pair, it breaks, but... Oh, I think if this has a 4 in it, then it breaks. Oh, unless it's 4-6. Right, yeah. Okay, I should not try to... I guess this can only be 4, 5, or 8. Seven in this box is interesting as well. Oh yeah. There was a 6 in here, so it can't go with an... Oh, unless it's a 20. Right, I keep forgetting it can have more than one multiple of 10. So I can't rule can't rule anything out of here yet. I think this is only 0 or 6, right? So this being a 4-6 pair breaks. Because this can't be 1, 3, 5, 7, 9, 2, 4, or 8. So this being a 4-6 pair breaks. So this is a 2, and this is an 8. And now I think this has to be a 0, right? Yeah. Oh, unless it's part of a longer segment. Yeah, there's still room for that in here. So this is not necessarily 0. I know that this is 2 and this is 8, but I don't know that this is 0. Because it could be a 6 to make 20 here. Wait, no, that would make... Wait, no, that would... I guess 6 in this box is down here. Nine in this box is in these two cells. Don't know how useful that is, but it's nice to... I'm not... I think this does have to be 0, doesn't it? Yeah, same, but I also... I'm worried there might be some really weird way of doing it that I'm missing. Is there an elegant proof that this has to be... Also, that... Well, it's just distracting. Okay. No, I think, yeah, I am reasonably satisfied that that is 0. Therefore, that's not 0, and that is not 9. And this is 0, 4, or 6. Now, one of these is a 6. I think they're... Oh, right. The 2 in this box rules 2 out of here anyway. 7 in box 1. Oh, yes, it is. Can't go next to this 4. Has to go here. Oh, unless this is a 9. 7, 9 pair here. With a 6 here and a 5 here. That works. Is that the only thing that works? I think it is. Yeah, it's the only... Yeah. Oh, or 7, 9 with the other 4, and 6 down here. Okay. Right, okay. Right. It could be... Okay, but either way, this has to be the 5. Right, because this could be 7, this could be 9, and this could be 6 with this. But I know that this is part of a 7, 9 pair. Either this 7, this is 9, or this is a 7, 9 pair, this is 6. So I know that this is either 6 or 9. Nice. I know that this is 0, 6, or 9. Nice. Almost as nice. This is 0, 9, this is 6. Okay. 7 in this box goes down here. Oh, this can't be 9 because it sees this 6, 9 pair. Nice. Alright. 1, 2, 3. I think this can only be 4 or 5, right? Because it sees everything else. It sees 1, 2, 3, and 6, 7, 8, 9. Okay, that's a 2, 4, 5, 8 quintuple. Okay, and this digit in this box goes in here with the 6, so there's no 8 here. So this is a 0, 3 pair. This can't be 3. Okay, so this is 3. This is 0. 2. Okay. 7-8 pair. Oh. Okay. And this is 4-5-9, with whichever of 4 or 5 does not go in here and here. 069, aka my college years. Oh. Yes, yes it is. This is not 1 or 2, so that is also 0. Oh, and this rules 2 and 3 out of here. So this is 1-9 or 4-6. Interesting that there's sort of that there is a virtual 6-9 pair, nice, here. It's not terribly useful, but it is a cool thing to spot. I think this is only 3 or 5. 3, 4, 5, 7. Oh, I should look at this column. 3, 5, 6, 9. Okay. Row 1, column 3, and box 2. Ooh, yeah, because this can't be either of them. Oh! Okay. Oh, that is cool. Nah, that's not 9, that's not 0, that's not 6, so that's not 3. That's not 6, so that's not 3. Oh, and that's not 9, so that is not 0. Okay, so this is a 4-5 pair. Oh, that creates a 4-5 pair with the also just 9 in this box can only go here now. This is, I think that, oh, this is a 0-7 pair. And this is a 3-6 pair. Is that resolved by anything? I don't think so. Maybe I should think more about this. This is either 10 or 11. Now, if this is 11, these need to sum to 9, which they can't. So I think this has to just be 4-6. Okay, but now this becomes all one segment. So I think this has to, oh, unless, no, this can't be a 0. So I think this has to be 5, 8. with this having a value of 3, and it can't be 1, 2, or... Okay, so this is a green 3. This is an S cell. 6 in box 3. Oh, yes, I should probably... Right, yes. That is also useful. Ah, 4 in this box. It can only go up here, so that is not 4. So in this box, it can only go here. Oh. This is 5 or 7. Zero, 2, 3, 5, 7. I know 2 in this column goes down here. Alright. What about... 0, 1, 5, 7, 9. Row 2, column 8 could also have had a value of 13. Ooh. Right. Okay, let's rule 13 out of here. Oh. It can't be 6, 7, 5, 8, or 4, 9. Yeah, it can't have a value of 13. Okay. that was quick. 9 in box 8 is placed. Ooh, yes. Only question is, does it go in an S cell or not? Exactly. All right. Oh. This is 7 or 8. 4, 7, 8. So there's an 8 in here. Three, 5, 6, 9. Getting close to triple of some kind here. Oh, this. God. Duh. Okay, yes, that gets quite a few things. Oh, this is 0 and 5, so that is just 1. Okay, so that's 1. Okay, and that is... okay, so this line is done. I don't need to... Okay, so that's a 3, 6 pair. Okay, so that's just a 9. Okay, I think from here it's just Sudoku. Well, SL Sudoku. This... I think this is done. That's 3. Wait, no. No, 8. 8. No, 9. Okay, okay. I'm little brain fried. Oh, yeah. Need to avoid any 10 breakpoint. I don't think I do if this is all one segment. Like, this is a 0, so this could still be 1. Oh, right. I need to avoid 10 breakpoint. Okay, yeah, I get what you mean. Okay, so there is still... Oh, yeah, that's interesting. Okay, yes, there is still some 10 lines logic to be done. There's sort of a negative constraint on 10 lines, which is... if my pencil marks are to be believed, this is the 2 in this column, and this is the 0, which resolves this. Like the logic better with the line starting in row 1, column 1, and 0 being between row 1, column 3, and row 2, column 2. Oh, yeah. Although you could have... Maybe if you'd drawn the line this way, that would be a way to rule out 0 from the edge of the line. Well, let's see what... I don't know the rest of the layout yet. Let's look at this. Yeah, you can have 0 at the edge of a line, so I guess... Ah, okay. 4, 7, 8. Yeah, it's 4, 7, 8. That's not 7. And that is not 8. This can still be any. Okay, so this can't be 5, or else that would be a break point. So this has to be 5. Oh yeah, yes, yes. Right. It sees a 4 in this S cell here. In fact, this is done aside from these. What? 0, 2, and 3. 0, 2, that's 3. Okay, that resolves this. Oh. That's already resolved. I missed these. I missed both of these. Alright. What's left in this? Four, 6, and 7. Well, there's a 6 in here with a 4 or a 7. Oh, and it can't be 4 or 6. Oh, and this 0 would be quite a bit harder to, Yeah, it can't be 4, 6. So there's a 6, so this is 6, 7, and this is 4, this is 7. That's neat. Okay, I think... Oh, and that also resolves this 8 and 7, and now the entire thing is done. It's just naked singles, right? 5... Wait, no, not 5. Oh, 9. Duh. Okay. 4, 8 pair. That's 4. That's 8. Nice! Oh, you already checked for breakpoints. Cool. Yeah, that was neat. Allowing... Yeah, 0 can't be its own segment either way, but it can still be on the edge of a segment. Right, okay. To a non-zero multiple of 10. So it's ruled out. Okay, yeah. Oh, and this 0, it's way harder to have this not be on the edge of the line, the way this line is drawn. Oh, wait, maybe if it went through here? Huh. Maybe that would rule out something else, though. Or lead to more chaos. But yeah, that was really neat. Yeah, it's always neat when you see some like really low fortress cells that shouldn't be possible. Honestly, I'd like to see someone do a version of this where like the negative constraint comes into play even earlier. But yeah, this was really neat. Yeah, this was a really I wonder, has ZetaMath done this one? I think he'd get a kick out of it. Oh yeah, shortest segment that keeps a line value, or maybe just add a 0 to one end of this line, of the example line, like a 0, 1, 9, 2, 8 sequence is considered 2 segments, not 1. That would, I think that would be... Yeah, alright. That was neat. And thank you for the GGs. Alright, yes. I might submit this to ZetaMath's bucket if it's not already in there. Remind me to check after the stream. Alright, I need to... I definitely will. Alright, I need to refill my water, but after that... Oh, no problem. Thank you for making it. That was a neat one. Alright, I'll be back in a couple minutes and start this. Alright, welcome back. Alright, see you when you get back, Ambrose. Alright, this is cogito ergo ... sum. I assume it's pronounced sum and not sum in this case. By oddly even. Normal Sudoku rules apply, so every row, column, and box gotta put the digits 1 to 9 once each. Dynamic fog. The grid is covered in fog. Placing a correct digit will remove the fog from its cell and possibly other cells in the grid. Uniqueness. For each of the constraints below, digits do not repeat anywhere in the puzzle. For example, if one arrow contains a 1, no other arrow can contain a 1. Digits along an arrow sum to the digit in that arrow's circle. Digits in a cage sum to the total in the top left corner of the cage, if given. It doesn't say whether digits can repeat in a cage. Maybe that just won't come up. Maybe the cages are laid out such that each one is entirely within a single box or a single row or a single column, or... We'll see. Region sum lines. Box borders divide a thick blue line into segments with the same sum. It's tricky to explain clue types when the grid is covered in fog, but I'll explain them as they come up if I remember. Clue outside the grid gives the sum of the first X digits from that clue in that row or column where X is the digit next to the clue. The question mark represents a total to be determined. And there's also zipper lines. Digits in equal distance from the center sum to the same total. If the line is odd length, that total is the digit in the middle of the line. Okay. Let's get cracking. 34, okay. I think these have to be a 3-4 pair, right? Because, they obviously can't overlap because the digits in this row sum to 45. So there have to be some digits in here that aren't on either of these. Otherwise, these would sum to either 45 or more than that. And you can't make 17 in less than 3 cells. Well, you can, but not if... But you can't make 17 in 2 cells if 2 is one of those digits, which it would have to be if it was an X sum. So this is a 3-4 pair. And the reason it's 3-4 and not 3-5 is there has to be more than one digit that is not on either of these. Okay, so this is a 3-4 pair. So either these are sum to 11, or these do. Without using 3 or 4. So it's 2, 9, or 5, 6. So there has to be a 1 on here. Does this have to be a 2? Is that what this means? With a 5, 6 pair down here? I think it does, right? Because there's no 1 on here. Right, okay, yeah. So this is 2. And this is a 5, 6 pair. Either here or here. And this is also 5 or 6. What does that mean? What is... Oh, okay. Whichever of these is 3, the remaining digits have to sum to 14 without 5 or 6? Wait, how is that possible? (17 and 17 is 34. 45 minus 34 is 11. But... Two 9. How does the 3 cell 17 sum work? But there's no way this is anything other than 2. Oh, wait, no. This doesn't rule 2 out of... God, right. This is 2, 9. Okay, I was doing that backwards, so this is 9. Okay. Okay, so there's arrows here. Jesus, okay. Whew, okay. Sorry about that. So if there's 2, 9, one of these is 3, 5, 8. No, one of these is 3, 6, 8. And it can't be this, because... Oh, unless this is 9. This is a 9 with a circle in it. Huh. So this could be a 3 with a 6 here and a 9. Then this is 4. I guess this could be 1, 2 with this being 7. But if this is 3... Could be 1, 2, 6. Is there always a 1 on here? And if this is 4, this is 1 or 5. What if this is 4, could this be 1? Would that break this? 3. Oh no, that's way too big. Okay, so if this is 4, this has to be 5. So I think this is only ever 5 or 6, right? Because if this is 3, this has to be 6, which makes this 9. If this is 4, either way, this is always 9. Okay. 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 That's really cool. Okay, now this can have a 9 on it, so these have to sum to at most 8. Now, if this is 4, 5, this is 1 or 7. If this is 3, 6, this is 8. So this is 1, 7, 8. And I guess this is 1, 7, 2, 9. Isn't this also... Oh no, this is 1, 5, 7, 2, 9. Okay. Yeah, that's a few too many pencil marks to be useful. Alright, so what does this 19 cage tell us? Well, it doesn't take any of these cells. In fact, it just has to be these 4 cells specifically, right? Oh, hey, Mello Robinson. I believe... Wait. In 4 cells, that's not terribly restrictive. Except, of course, these sum to a maximum of 5. So these sum to at most 24. Oh, and there's no 3 or 4 on here. Wait, don't these have to be 1, 2? Yeah, these have to be 1, 2, so these have to be 3, 4, 5, 7. Oh, this is weird. Oh, so that's 9 in this box. I believe your... I have 2 more in the queue before I get to yours and Chinstrap's collab. Well, 2 more including this, which I'm making decent progress on. So this is 6 or 7. This... Oh, this isn't 9. 9 in this box only goes here. Oh, there's a... Oh, of course digits can't repeat within a cage because of the uniqueness rule. Okay. I don't think I can use... Oh. But wait, 3, 4, 5, 7 now cannot go in any of these. So if this is 3, 6, 8, then 4, 5, and 7 have to go here. So this is in fact 4. So this is 7. So this is 3, this is 6, this is 8, this is 2, 9. 5, 7. That's 1 or 5. Oh, welcome back, Ambrose. So 3 in this box must go here. That rules it out of here. Just because of the cage. 7 in this box goes here. Okay. This being a 9 break any... Not necessarily. Oh, there is a 2 in this cage here. It's in one of these cells. Is that... I don't think that's... too powerful just yet. No, 7 is down here. If this is 5, then there's a 5 here, so that would be 7. But if this is 5, 7, that is way less powerful. Is there something to do with this digit on this line? I don't think there... Oh, new bag of cough drops, okay. Pardon me one moment. Alright, let's see, what is... Feels like I should... Is there something to do with the fact that... These are only from 1, 2, 6, 8. That's close to a quad, but not quite. If this cage does go up, this would be a quad, making this the same digit. Also ruling 1 out of here, making that 1. Is that an issue? Wait, this is a 1, 3, 5, 7 triple. So this is just a 2, 6, 8 triple. Okay. That is quite a bit easier to work with. These 2 digits are the same as these 2. So these are just from 1, 3, 5. Three here, 7 here. Where does this, oh. This must be fairly, okay, this, I've got 7 digits on here already, so they must be, oh, but wait, these, okay, wait. Okay, I know there are 9 digits on the, on region sum lines. Now the only question is what, because I can't repeat digits on a line, and this one immediately leaves this box, so it can't. So this digit can't go here or here. So it wanders somewhere else in this box. Somewhere else in this box. Now it could link up here, either this way or this way. Now, if it does, this has to be 9. But if it doesn't, I think, well, I know this is at least 5. And this could be a 9, 6 with a 7. Oh, wait, no. No, this cannot, right. This cannot be 5. Because of this 8. That would break this if it was 2 separate lines. 3, 4, 5, 6, 2, 7. No, that doesn't work either for this to be 6. Now, what if it's 7? 8, 2. Oh, I don't think it works for this to be 7 either, does it? It's a little harder to see, though. Because, oh! Quizzy Dan, thank you for the, raid. An itchy buffet. Welcome, Raiders. Okay, it's a little trickier to see why this can't be 7. Feasted upon my several mosquitoes. Been feasted upon by several mosquitoes. Okay. That explains the itchy buffet line. Now, I think... Okay, if this is 7, then these aren't connected, and 8 and 9 have to go on to here with 2 digits that sum to 5 but only differ by 1, but that doesn't work because of this cell. Okay, that is, I think, an easier way to spot that. Now, this being 9 does not, in fact, necessarily prove that these are connected, but it does make that a 2. Okay. Wait, does it mean this has to be a 7? Right, because the digits left over are going to sum, even if these aren't connected, the digits left over are still going to sum to 2 times 9. because it's going to be whichever. Okay, so this is a 7. And this is not 1, 8 or 2, 7, so it's 3, 6 or 4, 5. Oh, this is neat. Yeah, the mosquitoes are finally coming out of hibernation over here. We had nice cool weather for a few weeks at the start of summer, but now the heat wave is set in and it's all muggy and stuff. 9 in this box goes down here. Oh, but these lines are disconnected. It's funny how these are forced even though they are... Oh, the line in this box, it can't be 2, 7 or 3, 6 or 1, 8. So it is 4, 5, and this is not 4, 5. This is 3, 6. That leaves 1 and 8 in here. One of them goes here. And one of these is the other of 4, 5, which rules 5 out of here. And 4 in this box can only go here. Nine up here. Oh, you didn't think about the connected possibility. Well, I ruled that out. It's fascinating that this is forced even without knowing whether these are connected or not. In fact, even if they're not connected, it is forced, which is a different way of saying the same thing. Okay. What is... Ooh. Now what? Oh, this is 4, 5, 7, specifically. So 2 in this row can only go here. Ah, that gets me a few things. One, 3, 6, 8. Six and 8 are up here. And this is, oh, this is just a 1-2 pair. So that's not 1. Oh, this goes here. So this is not 6, 8. 6, 8. Oh, wait. This is 1. This is 1. It's forced by this cage going over here. I didn't even see that. Okay. Three, 4. Oh, this is 7 in that case, because this is the 4, 5. Okay. I haven't found the zipper lines yet either. Let's see what... What else do I know about... wait. So this line goes here. Where when did... oh. That's... oh, 7 in this box. Oh. Oh, yes, or 7 in row 7. That works too. Aha! Okay, so we have our first zipper line. Alright. This is 1, 2, 4, or 5. Oh, this is 6, this is 8. This is 3, this is only 3, 4, 5, or 9. Now, can it be, it can't be 3, because this can't be 1 or 2. 3, 4, 5. Oh, 9 in this column can only go here, so it has to go there. Okay, so this is 4, 5, it's not 7, so this is not 2. Oh, and this is 9. Do I have all the 9s? I have all the 9s. Nice. 1 in this box and column only goes there. 7 there. Oh wait, no, this isn't 8 either because of this. So this is a 4-5 pair. And that's a 4-5 pair. So this is only 1, 2, 7. It's not 2. Now if this extends here, oh, should I be thinking about... If this extends here, this can't be 4, 5, 3, 6, it can't be 7, and it also can't be 2 because this can't reach a 7, a king's move away because of this, and so forth. So it would have to be 1 or 8. I think either of those still technically works. Okay, so I can't... This digit goes here. Something obvious or something clever? This digit is here, this one is here. Hang on, I'm gonna... Ah, this... okay. This digit goes here. So one of these is 3. And more to the point, there's... okay. 2, 3, 6, 8 left in this row. Well, this is not 3 or 6. That is 2 or 8. This is 2, 3, 6. And for the record, this digit goes in one of these 2 cells, along with the other of 2 or 8. Now red goes down here, so in this box it goes here. What's left in this box is only 1, 2, 8. There's a 1 down here, which rolls 1 out of there, which places a 1 here. Aha! Okay. So you got 3, 4, 5, 6, 8. No way is this... Could this be... No, this can't be 1 or 2. This is 6 or 8. Ah, but I don't think it can be 6 because this can't be. Oh, well, just because of these, regardless of what either of these cells sees, it can't be 1, 5 or 2, 4, and it can't be 2, 3s because of the uniqueness rule. Okay, so this is 8. Now, does this have to be 2, 6? Oh, no, it could be. It can't be 3, 5. It could be 1, 7, though. Oh, but this can't be 1 or 7. So it does have to be 2, 6, and that's resolved by this. Alright, let's go with... Alright, wait. Oh, 2 in this box goes down here. Ah, 6 in this box now can only go here, which rules it out of here. In fact, that only leaves 2 spots for 6 in here, which gets me an X-Wing. Okay, so that's 8, that's 6. Oh, that doesn't quite... Okay. Okay, gotta remember one of these is a 6. Alright. This is yellow. Six in this box goes here. Alright. And then... Oh. Ah, 8 in this box. It can only go here. Alright. Okay, so that's yellow, so that is 3. I can probably get rid of the red-yellow coloring now. I think that's served its purpose. Especially because 3, 4, 5... Oh, that's just a naked 2. And there's no S cells here, so... That's 4. 5, 6, 7. I think either of those can still be any of those. Alright. Oh, and there's no... Okay, so that confirms that this is only... Oh, this being 8 will... Anyway, okay, yeah. Alright, what about these columns? This is 4, 5, 3, 4, 5. Oh, what's left in this? 2, 3, 5, 7. 3 in this row. Oh! Huh? Oh, 1, 3, 4. No, wait. Huh? Well, this is 2 or 5. Oh, okay, it's just 5. Okay. Hopefully I can shed a little more light on what the heck is going on up here, because... Oh, that resolves red and yellow. This is 6, 8. This is 1, 6. Well, this can only... What? I am very confused by this. Hopefully when I get a bit more... Oh, is this 1, 4, 8? Well, I know this isn't 6. This is 1. What? Oh, right. This just doesn't do anything. Okay, it took if it's a two cell zipper line doesn't actually do anything logic wise. Okay, that's what I. Okay. Yes, took me entirely too long to realize that. Okay. Oh, 45-45, a very Sudoku-themed time. Alright, thank you for the GGs. Oh, hey, Juggler. Welcome. Sneaky indeed. Alright, next up is Marty's entry. Oh boy. Counter product I saw the word product in the title and wondered, does this involve multiplying? And oh boy. Yes, okay, so normal Sudoku rules apply, so every row, column, and box gotta put the digits 1 to 9 once each. A cage's product, the result of multiplying its digits together, exactly equals the number of cages with that product. Okay, how many cages are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. There are 36 cages. Yes, exactly. Can't wait for Sudoku rules to start employing integral calculus. Okay, so there's 36 cages. So I can't... It also doesn't say whether digits can repeat in cages, but I don't think they can anyway just by normal Sudoku rules, right? Because every cage is either within one row, within one column, or within one box. Okay. 36. Now I can use the same digits twice. I can have a 1 cell 2 and another 1 cell 2 cage. But, okay. I can't do too, like... Obviously, I can't have 2 digits in the same cage that are both 6 or higher. Or even 5 or higher. What's the maximum number? No, okay. Are there any boxes here? If I put a 9 in a cage, like if that's 9, that's 1, 9. Yeah, I don't think, because if I put a 9 in a cage, then all 9s have to go in cages, either alone or with a 1. Because there's no way to multiply 2 digits in the same row, the same column, or the same box together to get 9 except 1 9. So I don't think 9 can be a cage total. Good question, Chinstra. I think it might be, because, like, what about 7? Well, there's some leeway there, because I'd only need 7 7s rather than all 9. That would still be tricky, but doable. Obviously, 13 is a no-go. I'm assuming it's probably just 1 through 8. But how exactly do I... How do I prove that? And for that matter, even if I did know that, how would I actually get started on that? Obviously, any prime number higher than 7 is a no-go. Wait, I don't think I can ever put 9 in a cage. Oh, could I do 18? With like half of them being 9 2s, the other half being 3 6s, with or without a 1? Is there some reason that wouldn't work? This... If there is any digit that does not go in a cage, that never appears in a cage... then those are all it. Now, what digit can that actually be true of? Not yeah, if 9 isn't in a cage, that gives us a lot of stuff. So I know that 5 and 7 appear at least once in at least one cage. Because, like, 5 in this box has to be in a cage. And 7 in this box has to be in a cage. Oh god, that's right, you'd still need all the 9s in a cage. Which you can never have. You can't have all the 9s. Well, wait, if there's any digit that's always in a cage, do I know anything about... Okay, let's assume... Okay, it would have to go in here. This would be 9 with a 1, 2, I think. Same up here. Ooh, I think that breaks this box. Yeah. Right. Yeah, okay. So I don't think you can ever put 9 in a cage. Okay, so that does in fact... That gets quite a few 9s. Along with... Oh. Here. Oh. That's 9. Okay, now, what can I do with 8 in a cage? Well, it can go in some cages alone and then have 2, 4, or 1, 2, 4. With it in other cages, so that's a bit more flexible. Okay, and oh, you also can't. I also can't make any cages that are the double of a prime number, right? Because its prime factors are 2n, or at least not if that double of a prime number is greater than 9. So if 7 is in a cage, it's by itself, or with just a 1. Can 7 be... Exactly. Yes, we were thinking the same thing. So 7 only goes in 7 cages. I think that forces it here, in this box. Well, only barely. I'm only barely beating you to these deductions. I could go 7 could go with a 1 here. Gonna restart. Restart what? Oh, I forgot to let Marty know. So there's 7 cages that sum to 7. So 7 appears in a cage exactly that multiply to 7. So 7 appears in a cage exactly 7 times. Now, is there any other box where I know 7 doesn't appear in a cage besides this one? Well, I know 7 in this box only appears in this column, so down here either one of these is 7, or this is a 7, and this is a 1. 7 can't go in here. Can 5 go in anything other than 5 cages? I don't think it can. There's no... The only way to multiply to 10 is with 2 5. And I don't have 10 of those. 15, that's 3 5. Its prime factors are 3 5, so that's the only way to multiply to it. And 20. Oh, you still need a 5 in each cage. Yeah, that wouldn't work. Okay, so 5 can only go in 5 cages. I think we are proving that the numbers in the cages are that the products of the cages are exactly 1 to 8, 1 through 8, which is what I assumed it would be when I saw that there were exactly 36 cages. But it's nice to have a little proof of that. 5 and this box goes here. Oh, this could still be a 5. I was about to say, is this a 5-7 pair? But no, the 5 could still go in here. Oh, right, which means every 3-cell cage must have a 1 in it. This creates an X-wing. That's not... okay. So this is not 1... okay, so this is a 5-7 pair. So this isn't 5 either. Okay, so there's a 5 in here. Alright. Yeah, but we can't get... Or could we get... 4, 6... Oh, could we have 24? Oh, no, not if we also have, right, it could be... Okay. Going to... This probably wouldn't work, but we could have we could have 24, 5, and 7. There's almost certainly no way that would work. Right, because these... We have 4 different cages in one box. There's no way that would work if we only had 3 different totals. Right, okay, so yes, there's... 24 doesn't work. Well, we could... I mean, there's ways around that. If we did have 24, we could make do with 3, 8, and 6, 4 combos to free up a few extra digits. So I don't think... I think we could make 24... 24 cages. Well, 3, 6, and 2, 4 goes 9. Oh, you're right. That still only gets us to 18. And using 3, 4... Oh, okay. Okay, that's a... that is a more elegant way of... I think this has to be 5, 7 as well, because this can't have a 1 in it. Okay, I guess now we're looking at the question of where can the 1 cage whose product is 1 be? It's not in this box, not in any box with these in it. Not here, not in any of these. Not here. So it could be one of these or this. So one of these is a 1. A 1 in here and a 1 in here. I think that rules 1 out of here, which makes that a 1. And there's sort of an X-wing, and one's here. So there's a 1 here. Oh. Wait. Oh, I think I broke something. There's no... Okay, there's a 5 in here, but I don't think there's a 7, because otherwise there'd be a 7 in here, which doesn't work. So I think 7 in this box has to be here, doesn't it? Because these corner cages rule 1 out of here. Can't go in a 3-cell cage. Yeah, I think that has to be the 7. And one of these is a 7. I'm going to mark every 2-cell cage that I know doesn't have a 1 in it. Oh, right, so every other 7 must go in a cage. So in this box... Right, so these are our 2 7s that are not in cages. So in this box, must go there. Right. So that's 7, okay. Goes down here, and thus, okay. What's the max digit I can put? These are just from 2, 3, 4, right? Wait. Oh dear. Okay, some of my logic is wrong because, at least one of these is going to multiply higher than 9. Okay, I don't think any of my pencil marks are wrong, because I didn't actually use the false deduction that everything has to be less than 10. I think there's a 12 in there somewhere. Or wait, there could be like a 16. In fact, I think there has to be a 16. Hang on, I'm going to go back to... Right, because I used that to... Okay. Yeah, the issue is, what do I do with the 8? Oh, it can go by itself. The 8 can go by itself. So it probably is 12. And I think, yeah, this is forced to be 7, which forces that to be 7. Nothing with prime factors above 3, right. Yeah, 7 is definitely only... Okay, but I think some of the ruling of 1s out of these cells might have been a bit spurious, because, because now that I know that there is... I thought I had accidentally proven that the cage, that all the products were 1 through 8, but I don't think that holds. Oh, 7 in this box is forced here. Seven can't go here because this can't be 1, and it can't go here because this can't be 1. Okay, so it is forced down here, which forces it here. Yeah, 24 still didn't work. So yes, I do know that each 3-cell cage contains a 1. But I don't know that there's a 1-cell cage with a 1, which was how I ruled 1 out of here. And I don't think that was valid. I know that the 1 in this box goes here or here. Although it would be pretty tough to have to have the missing digits from 1 to 8 include a 1. Oh, that's 7. Yeah, 16 does seem bad. Oh, yeah, especially because you would need all 8. Right, okay. So 8 in this box. It has to go here. So I think this is a 5-8 pair. Oh, so that makes this 8. But this isn't necessarily the only 8 that's not in a cage, because I could make up some of the difference with 2 4 pairs. But now I know that, well, 5, 7, and 8 sum to 20. So the remaining digits are exactly 16. 12 and 4, or 12 and 1 and 3. Feels like plausible, though well, it can't be 13 and can't be 15 and can't be 14. And it can't be 16. Right, it is 12. So there is 5, 7, 8, 12, and either 4 or 1 and 3 to finish. Yeah, we don't, there's no 6 cages total. So the 6 in this cage must go with a 2. Either this is 2, 6, or this is 1, 2, 6. With 3, 4 as the leftover. Okay. So these are both 12s. I'm gonna green 12s when I find them. Oh, and every 3 cell cage must be a 12 in that case. Because everything else is 2... Oh no, we could have 1, 2, 4 to make 8. Dang it. Okay. This could be 2, 4, or it could be 2, 6, or 3, 4. Oh. I don't think these can be the same 2 digits, otherwise they'd have to both be totals down here. So... but they could both be 12 if they're different totals, and like these digits go in here. Yeah, 3 cell cages still do need 1, and oh yeah, either 2 or 4. So each 3 cell cage has 1 and either a 2 or 4 in it, so this is not 2, 4. So it is 12, and these are different 12. Maybe I should do green and blue to mark the difference between 2, 6 and 3, 4. So like whichever digits go in here, they also go in here with a 1. But if this is 1, 2, 4, right, so this has to be blue, right? So this is 1. Because if this is 1, 2, 4, this breaks. So, okay. Oh, that's 1, okay. Now, I think this could still be 2, 4. And so could this. So I don't know that this is either green or blue. I know 5... Oh, this is a 5-8 pair, right? So these digits go in here. They go up here. Wait. Ooh, that's... I don't think they necessarily go in the same cage, because I could put one with which, like, a 3 or a 4, if the remaining totals are... Because we still have 4 left over to count. So we either have 1 cage and 3 cages, or 4 cages. Oh, but this... 2, 3, 4, 6... Yeah, this cannot be 8. And in fact, these both see this, so this has to be blue. This has to be green, and now these look across and force this to be green. Well, actually, no, because this could still be a 2, 4. And, yeah. I think this could still multiply to 8. Oh, except... Right, 1, 2, 4, that would make this 2... Yeah, okay. And now this has to be blue. Fascinating to... Oh, this can't be blue or green. If my logic thus far is correct, this cannot be blue or green, so this is 1, 2, 4. This is a 3, 6 pair, and I think this is a 2, 4 pair. 8 in column 1. Oh yeah, it goes here. So 8 in column 3 goes... 8 in box 1 goes here. Or did you mean box 1? This is 2, 3, 4, 6. This is 5. This digit goes here. Ah, this digit goes here. Wait, does that mean these have to be 2 and this has to be 4? Isn't that what that means? Because this cannot go with a 1, so this, I think that is forced. Because this can't be 1 or 3. And this digit goes here, but it can't go with another blue, so it can't be blue. I think that is forced. Oh, that is cool. This is 6. Ah. Oh, and I can't have a 6 total in here, so 6, okay. So this is 1. So that's 1 and that's 1. Oh, this is a 1-3 pair. In fact, that is 1, that is 3. Okay, so there's no 4 cages. There's 2 more 3 cages and 0 more 1 cages. Oh, in fact, I've got all the 1s. What am I doing? Oh, this is 2, 6. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I've got 9 12 cages. Oh. That helps. Make that 10 12 cages. So this can't be 2 4 or 2 6, so it must be 3 4. It's 11. Okay, I am almost out of 12 cages. Oh. Make that completely out of 12 cages. I would love to see a setting video on this one, because I have no idea how you could possibly make this, like, actually work. I mean... This seems impossible to set. No, well, this is 3, 5, or 8. Five greens and 7 blues. Interesting that greens and blues are out of balance. I guess this... Okay. How many 8 cages do I have? I have 3. And an extra one in here somewhere. Oh, and one of these. This is 3, 5, or 7. So 4 in this box can only go here. And this is 3, 5, or 8. Oh yeah, I have another 8 cage down here. Yeah. Okay, so I got 6 8 cages. Wait, where can I even get... I can get another one here. Oh dear. That's 6. I can get one in here to make 7. Oh, here's the last one. Okay, so I inadvertently proved that one of these is 8, which creates an X-wing on 8s, making that 8. Oh. Well, I can't put a 4 here. This is a 3-7 pair, which makes this a 4. Now this has to be a 5, right? Making this a 4, 9. Oh, well, once I had 8, this was 5 just by the column. 3, 5, 7, 8 quad. So 4, 6, 9. 4 in this box goes up here. This is 6 or 9. Nice. Eight's a line in middle band. Oh yeah. This is a 5, 6 pair resolved. Oh, and that's gonna resolve, this. Oh, that's just gonna unravel the, well, most of it anyway. Oh yeah, the whole thing. Alright. Okay, that is all the cages done. So from here it's just Sudoku. That is 4, helpfully pencil marked earlier. 6, 9 pair here, nice, and also resolved. 5. Okay. That was neat. God, the way these were forced, the resolving, forcing this to be 2, forcing these to all be 2 was really amazing. That is... Yeah, I would love to see like a video on how you set this, because that is just, it's incredible to me that this exists. And this is one of those where, how does this exist? Thank you for the GGs. All right. All right. Every cage has the same product, one that was similarly very finicky. Yes, I can imagine. To set, not to solve. Yes, that's... I can definitely imagine that. Alright, next up we got Self-Help Aisle by Mela Robinson and Chinstrap. Normal Sudoku rules apply, so every row, column, and box. Gotta put the digits 1 to 9 once each. Dynamic fog, another dynamic fog one. Subset index lines. Digits on a line form a non-repeating consecutive set in any order. Digits along the line are indexed by their relative value in the set. The first person position index is the lowest digit. Length 5 line with the lowest digit 4 could be 4, 6, and 5 index each other, and 7 and 8 index themselves. Okay, so it's regular index lines, but each one is shifted by an unknown amount. Okay, that does vary up the logic a bit. Lines do not cross themselves or share cells with other lines. That'll be good to know when the fog starts getting cleared. Each circle point to a line, and a digit in the circle counts how many digits on that line index themselves. For example, a length 5 line that is 4, 6, 5, 7, 8 would have a self-reference count of 3 because the 4, 7, 8 are all self-indexed. Okay. Okay. With you so far? Okay. Now, if this digit is 4, this is 5, 6, 7, 8, or 6, 7, 8, 9. But if this is 4, this could still... Oh no, this can't have a 5 on it. So if this is 4, this is 6, 7, 8, 9. Huh, interesting. Alright. In fact, this is either 1 through 4 or 6 through 9. Now, if it's 1 through 4... Oh, that doesn't work, because then these two would need to be the same as these two, and then this cannot go in this column. Okay, so this is 6, 7, 8, 9. And this only determines the order. And, okay. That is... Okay. Oh, but wait, this cannot have 3. Neither of these can be 3. Because you can't have 3 cells on a 4-cell line indexing themselves. You can have all 4, you can have 2, and I think you can have 1 if you just shift... Wait, can you have just 1? Like, okay, say this is 6. No, because these are always even. Right, the number of self-indexes is always even. At least on an even length line. So this is a 2-4 pair. So this does not have 2 or 4 on it. That's not 5. And there's always a 6, 7, 8 on here. So this is 9. Oh, and this is 5, 6, 7, 8. Leaving 1 and 3 here to finish off the box. If this isn't 5, it is the same digit as this. So this is either 5 or this. So, what does... Huh. Why would... Okay. This digit goes down here somewhere. Let's see, if this is 6, this is 8. So this is 5, this is 7. So this is 7. If this is 7, this is... Okay. What if this is 5? Then this is 7. This is 6, 8. Oh, wait. I don't think... These can't both be 8. So, this is not 7, because otherwise this is the 2, this is the 4, then this has to be 8. One of these is 8. Okay. This is not 7, so this is not 6. This is 6, 7, this is 8, 9, then this is 2, this is 4, so this, yeah, so I'd have 8s. Okay. Oh, and these can't both be 7, but one of them has to be. Right, so this is not 6, this is not 5. There's a 7 in here. Now, if this isn't 7, then this isn't 8. So, either this is 8 or 7. I think this is a 7-8 pair and this is a 7-8 pair. Is that... Wait. Is that... Yeah, okay. Wow, okay. It is surreal that I was able to get this just from this. Wow, this is, Okay, the only digit that these two lines can have in common is here. This has a 4, 5, 6 on it. The 6 has to go up here. 7A. Okay, so there has to be something high. The minimum digit I can put on here is 3. Because there has to be a 7 or an 8 on here. There's a 5 up here. Oh. Well, I know this can't be a 5. But this still could be if this is 5. Now what about 6? Well, I know there's a 6 on here. Again, this can't be 6, because it would rule 6 off this entire line. So this can't be 5, 6, or 7. I mean, it couldn't be 5 anyway, because of this. No, it also can't be 6, 7, or 8. Oh. But it also can't be 9, because then this is 6, 7, 8. And now I can't, there's 2 digits from 6, 7, 8 that can never go on this line. So I think this is only from 1 to 4. Oh, right. This isn't 1, 3, or 5. It's only 2, 4, 6, and it can't be 6 because of this. Because non-self-indexers always come in pairs. So the circle that points at a line is always the same parity as the length of the line. Okay, this line can't have a 5 on it. So it is just 1, 2, 3, 4. If these have any crossover, it would have to be here, and this can't be a 5. So this is 5, 6, 7, 8, 9. Oh, so this is 5 or 9. These are from 7, 8, 9. Oh, right. If it's 7 or 8, then it repeats on the line. Also, hi, Screaming Ice Cube. Okay. This is not 7 or 8. This is just 6. So, this has to be a 7-8 pair now, and this is a 5-9 pair. So this indexes itself... Wait. Oh. This has to be 7. Took me a while to spot that because I assumed that this was more involved in. Oh wait, this digit goes here. So this is a 5-8 pair, and there's an 8 down here. This digit goes down here. There must be a 4, 5, and 6 on here. These are not 5 and 6. Must be a 5, 6 here. Oh, what's left in this column? 1 and 3, right? Yep. Do I know which of these two this is, or vice versa? I don't think I do. This line can never have an 8 on it, which means it can't have a 9. So there's a 9 up here, this is an 8-9 pair. So there must be a 3, 4, 5, and 6 on here. The 5 must go down here. And 5 there. Not there. Five on this line can only go here. Oh, there's a 7 on the line over here. Okay, so this is 2 through 7. 2, 3, 4, 5, 6, 7. Just because 7 can... okay. Oh, so 1 in this row can only go here. And this digit must go in one of these cells. Not sure how I want to notate that, but this... okay. This is only from 2, 3, 4, 5. That's very close to a quad here. Okay, so 1 and 9 in this row only go over here. 9 in this row only goes over here. Two, 3, 4, 6, 7. Oh. Wait. Obviously this can't be 3 or 4. Yeah, this is 2, 6, or 7, which in normal index lines corresponds to 1, 5, 6. Now what about here? 2. 2 can't go there. Oh, 6. I think this is only from 2, 6, 7, right? This is also not 3 or 4. I have 5. This isn't... Oh yeah. One of these is 5. Oh, except this can't be 3, because one of these has to be 2, 4. So this is not 5. What about 4? That's fine. Okay, what about 3? 2, 3, 4. Okay, that is... Wait. I think this is... No, this is 3. Then this is 4. This is 5. Yeah, that works. Okay. 2... 4... Wait. Oh. I think this being 2 breaks, because then these both have to be 4. 4... 2, 3. Okay, if this is 4, this is 2, this is 3. This is 5. Oh, then this is 7, this is 6, because... then this is 6 and this is 7, because then this is 2. But, annoyingly, that works. Alright. If this is 4... Wait, this can't be 4, because that breaks this. Oops. So this is just 2 or 6. Now, if this is 6... Oh, I think it breaks for this to be 6, because where does 6 go on here? It can't be here because this can't be 5. And it can't be here because this can't be 3, 4, 5. So this is only ever 2. Okay. And now... This is not 6 because this is not 2. And this is not 3 because this is not 2. Oh, more importantly. 2, 4, 6, 7, triple. Okay, so 1, 3, 9. I caught the mouse before it fell. Nice. That is not 3. Okay, 2, 4 pair here, so 1, 3 pair down here. Column 4. Oh, hey! Puzzle Me, John. Yeah, I spotted that just... Caught our deadly in box 5. Were you hoping I'd get stuck on that? Oh wait, this is a 3, 4, 5 triple now. So there's no 4 up here. So this is 4. Four, 7, 9. Wait. No, 4, 6, 7. We figured lots would forget to the end. Well, sorry to stymie you. Not this. 2, 4, 9. Oh, this is 4 now. So there is a 4 down here. What can this be? Ooh, good question. Not 2, 3, 4, or 5. This is 1, there's a 2 down there. Should make this a 2. One, 6, 7, 8. Well, there's only 2 self-indexers on here, so even if this is high, I can still put some low digits after it, so it doesn't have to be, it's not the low... Is there a reason why it's the lowest digit? Oh, what? I think I broke some... Oh, it's this. Okay. I don't think this is necessarily the lowest digit on here. Unless there's... No, the first position indexes the lowest digit. So this is the relative position of the lowest digit on here. Modulo, like... Well, not modulo, but... Yeah, it's tough to it's tough to grasp, but this the later... Well, I still don't know. I know there's a 4, 5, and 6 on here somewhere, because it does have to be a set of consecutive digits. But, like... Oh, this is 129. Oh, but there's a 4 on the line. It does have to go here, so that makes that a 5. 3, 4. That helps. For instance, it makes that a 5. Now that's interesting. Could this be a self-indexer? Then it would be 4 through... I would need to put the 4 through here. Okay. Then this would be indexing the 4. So it would go here. If it's here, this is 6. If it's here, that's 7. And if it's here, that is 8. Oh, does every line necessarily have a circle pointing to it? Oh, box 3. Oh. Okay, yeah. Right. Okay, that is... Oh yeah, this can't be 1. Because if it's 1, there has to be a 2 on the line, it can only go there. And now this would have to be 6, not 5. What else can I do with... Oh, I don't think I can roll anything out of here just yet. Okay. Then there's... Another 5 down here. I should also think about... Well, there always had to be a 6 on the line, and... But now if there's no 1 on the line, there has to be a 7. Oh, that's a bit more... Has to go down here. Oh, yeah. Oh, isn't this just 1? Because it sees everything else. It sees, yeah. Yeah, this is forced to just be 1, which resolves this 1, 3 stuff in here. This is 4, 7 with either a 3 or a 9. Now, either of those seem plausible. If it's a 3, then this is 8. If it's a 9, then this is... Oh no, there could still be a... Right, no, this can't be a 2. There's no 2 on here, because it would have to go here. And it would be the lowest digit. But it wouldn't be indexed by this. It would have to be indexed by a 7. Right, so this is always 8. And this is for 7 with either 3 or 9. Oh, as Ambrose was attempting to tell me, no, 2 cannot go on here. Oh yeah. So it is. Just leaves a 1-9 pair, which is resolved by this, to finish off the column. Seven, 8 pair here. Okay, there's 3, 6, 7. Yeah, okay. How am I doing? Alright. If this is... If there's a 3 in here... It has to go here. And I think if there's a 9 in here, it has to go here. But wait, 4 can never index itself. So if this is 9, this is 8. I think the line's broken. Oh no, 5, 7 are the self-indexers. With 6 and 4 indexing each other and 8 and 9 indexing each other. Whereas if this is 3, that's 7. That's 4. Yeah, that works either way. But I think this is always 4, isn't it? Oh, yes, as chat points out, this is always 4 either way. Oh, okay, so now we get into... I wondered when the lines do not cross themselves or share because so far we haven't had any ambiguity about where lines go, but now we're getting into that. Okay, there's no chance that this is 9, because there's no way to draw a 9-cell line that doesn't... There's only 7 cells here. And I think a diagonal line would be visible through the fog? Oh, I think I can see it here. I think I can see the very corner of a line here. what is... Okay, so I don't need to rely on foggy corners. Alright, so what is left in this? It's 1369, right? There's a 1 up here. Well, okay, if this is even, then I know this line has an even length. So... I mean, it's technically possible that this doesn't... Wait, no, because then this would be... Right, okay, so this line has a 1 on it. Yeah, that... I imagine that would be very annoying, and that is one of many reasons I have not yet set any, fog puzzles. What is... Right, it can't have a 9 then. Right, okay. This is 4. Okay, so this is 2, this is 9. Alright, so, Oh, okay. I was wrong that it has a 1 on it. But it can't have a 9 on it. So, okay, so I don't have to rewind too far. I did. But I don't think this can be a 1 because it would need a 2 and a 3, and it can't get them anywhere. So this is not 1, this is 1, this is 6. Oh, this is just 3, okay. Okay. Uh, 5, 7, 8. This is 4, 5, 7, 8. Now this line has a lot more room to work with. Yeah, so was I at first. That was causing me a bit of trouble. But I got hung up for the same reason you guys did. Now, this line has way more room to work with, so it's not necessarily not 8. Because it could come up through here and get... Wait, no, you can't... Oh no, it could be if it was... This is 236. Three, 4, 5, 6, 7. No, that I don't think 8 works. Oh, unless this isn't even the... Yeah, okay, so I got 149 here. This is not necessarily the end, either end of the line. Oh, wait. Oh, if the circle is bigger than 4, the line needs a 5, and it can only get it here. And if it's 4, this is still 5. Oh, that is cool. That is cute. Alright. Okay, so we are... I mean, for all I know, this could take every cell in this box. Okay, but this is... If this is 2, it is the lowest digit. Because if there's a 1 on here... Okay, so the line does not get a 1 on it in this box. Oh, in fact, the line can never have a 1 on it at all. Oh no, if this is a 3, it could. If this is a 3, it could get a 1 down here. Okay, never mind. I have to do something else. Okay. I know there's a 4 in here somewhere, so if this isn't 4, this is 4. But there's no way for the 4 to appear after the 5 if this is... seven or 8, right? I mean, if the 4 appears after 5, this is already not 8. If it's 7, doesn't this have to be 4? It's a little tough to explain, but I think... Like, if this isn't 4, then it's 7 or 8, and this is 4... And since lines don't cross themselves, I know that this, just by the fact the lines don't cross themselves, I know this digit is after this on the line. So this would have to be 7, but then these are the only 2 that don't index themselves on a 9-cell line. That doesn't work. This is 4. Oops. Oh! Hey, LM Damasi, been a while. How'd your stream go? Welcome in. Hi, Skojo. Aww. Remind me to check the VOD of that. If there is one. Well. Yeah. Or, there. Yeah, I'm more understand. Ooh, wait. Okay. This line, yes, yes, I realized the instant after I'd said that that was, yeah, probably smart. All right, bye. Thanks for the raid. Oh yeah. So this is only 3 or 6. So close to a quad. Ah, well. All right. So, like, how can this... Oh yeah, this is not on the line. So this is the last digit on the line. This isn't on the line because it would repeat in this row. So this is the last digit on the line. Oh, it has both of 2 and 3, in fact. So, it takes a 4 in here. Oh, right, so it can't get 7 and 8, so that resolves these. Aha! And the only question is whether it also takes a 1. Now, if it doesn't... Oh, wait, this indexes itself. And this doesn't... Wait, doesn't this have to be a 6 in that case? Regardless of whether it takes itself or not, whether it takes a 1 or not. Alright, this isn't 3. Oh, that doesn't rule 3 out of either of these. But this is not on the... Oh, this is a 4. Oh, and that tells us whether it takes... Okay, so it doesn't. Okay. 4 and 7... Oh, and 2 and 3 have to index themselves. Okay. 1, 9 pair makes that 8 and 9. Okay, 6, 8 resolved. Oh, and that's 1 and 2. And I think that should resolve the entire thing. Woo! All right. All right, thank you for the GGs. All right. Well, that was neat. Let me know if you publish it to yeah, let me know if you publish this. I would be glad to register us all with that. This was neat. All right. Oh, Soder. I should probably wrap up there. Want to save my voice for tomorrow. Got a performance tomorrow. As of this week, my Saturday's open back up again. I should be able to do a short game stream this Saturday. Get through a little more of my Steam backlog. I'll be back. I'll start off with this on Monday. We got a few more things, and yeah. All right. Alright, who's on to raid? Oh, Janine's doing Deltarune. Alright, I will raid Janine. I'll be back on Saturday with some gaming, and Monday with more puzzles. Alright, meantime, thanks for joining me, and bye!